Okay, in this video we want to solve the system of equations using Gauss-Jordan elimination. This is like the number 2 on your entrance card problem for January 29th. So the idea here is that you're looking for three numbers, and the three numbers are labeled as follows. They're labeled x1, they're labeled x2, and they're labeled x3. Now usually this type of notation is kind of cumbersome, so I like to change the problem. I think the problem is easier to kind of get a feel for it if we look at it in a different way. So let me show you how I think about this. You think of the question like this. I'm looking for three numbers, x, y, and z, that satisfy all three equations. And what we're trying to do is find a way to solve this, but we're trying to eliminate a lot of the writing. There's many different ways of doing this, but one of the ways that we like to use is this Gauss-Jordan elimination. And so what that means is that we translate this system right here that we have in all these numbers, and we only look at the coefficients, and the coefficients are exactly what I'm underlining, these numbers. That's all that's really going to matter when we try to do this. And so, and right here there's a 1 that's not written, and so on. And so these numbers we're going to write in a matrix that looks as follows. They're going to look like this. So we're going to have a 3, a 2, and a 1 to represent this first column right here. And then the second variable is the ones in front of the y's. So notice that these all have y's in here. These will be 6, 14, and 4. And then the ones in this column, those numbers would be negative 14, negative 32, and negative 9. These represent the coefficients of the z values. And then here I have negative 14, negative 12, and negative 5. And notice that I put this extra line there. And the idea is, in the back of your mind, this is what you want to think. These are the numbers in front of the x values. These are the numbers in front of the y values. These are, and finally, these are the numbers in front of the z values. And I'm sorry, this is supposed to be a y right here. And then these guys at the end, these are the constants. Okay. And so what we're trying to do is find an easy way to solve this. And there's some rules and there's some ways of doing this that it's a little bit easier. And so one of the first ideas is that if you see a 1 like this one, for example, we have to figure out how to move it to this position right here. And so you're only allowed certain moves. And so the idea is to go back to these equations. Would it matter if I switch these two equations? Does it matter which order I do them? And the answer is no. The order that I do those don't matter at all. And so what I write here to remind me of what I did is I say I'm gonna switch row 1 with row 3. So that's what this notation means. Switch row 1 with row 3. And so what I'm gonna do is I'm gonna rewrite this matrix, but I'm gonna switch row 1 and row 3. So row 1 now will be up here. Sorry. Actually, I didn't want to do that one. I'll do this line right here. And row 3 is not going to be down here. 3, 6, negative 14, and negative 14. But I'm not switching row 2 at all. So row 2, I'm just going to leave it alone. Okay. So the purpose of that move, the only reason for me even wanting to do that is because I wanted the 1 right here. That was the reason for that move. All right, so why do I want that 1 there? That's the question you should be asking. What's the importance of that 1? Well, that 1 is going to allow me to get rid of these two coefficients, get rid of these two numbers, and this is the way I'm going to do it. I'm going to take the second row. I'm going to make this in purple now. I'm going to take the second row, and then I'm going to subtract 2 times row 1. Here's the reason why. The reason is that this second row, this is a 2. And if I multiply the 1 by 2, by negative 2, 2 minus 2 is 0. I want to find a way to get rid of it. And that's the reason why I use negative 2. Because I'm going to multiply it. What this means, this notation is telling you here, this negative 2 is telling you multiply everything in row 1 by negative 2. Which means that this number here will be a negative 2. This will be a negative 8. Negative 2 times negative 9 will be 18. And negative 2 times negative 5 would be positive 10. Okay, so the way I would do this, oh, and one last thing. once I compute this, I want to store the answer in row 2. I'm basically replacing row 2 with something new. This is the same as adding two different equations. Now, I'm not changing the first row. I'm also not changing the last row. The goal of this move is only to switch the second row, only to change it in a new way. And so what I do here then is follow my steps. So I take this 2 and I add it to this negative 2. 2 minus 2 is 0. So I write the 0 here. Then I take the 14 and add it to the negative 8. 14 minus 8 is 6. Then I take this negative 32, add it to the 18, that's negative 14, and I put it right here. And finally, I take this negative 12 and add it to this 10, and I get negative 2. Okay. The key here, though, was to notice that I multiplied row 1 by negative 2. I think of this as a negative 2, not a minus 2, a negative 2. All right, well, now the idea is I want to get rid of this 3, but I want to use the 1. So what number times 1 gets rid of 3? Well, what I want to be able to do is multiply by negative 3, because negative 3 times 1 would give me a negative 3. And so that's what I say. I say, okay, I'm going to take this row 3, and I'm going to subtract 3 times row 1, and then I'm going to replace the answer in row 3. So the focus is this guy right here. And so again, I'm going to scoot this up a little bit. I'm not changing row 1, so I'm going to, and this is the process I always do. Whatever I'm not changing, I go ahead and write it right away, because otherwise I'll get confused. I'm not changing row 2. And then what I want to change is row 3, so that's the one I'm going to do in a different color. And so again, the key is right here. I'm multiplying row 1 by negative 3. So 1 times negative 3 is negative 3. 4 times negative 3 is negative 12. Negative 9 times negative 3 is positive 27. And negative 5 times negative 3 is 15. Okay, and now I go ahead and do the following. 3 plus a negative 3 is 0. 6 plus a negative 12 is a negative 6. Negative 14 plus 27 is 13. And negative 14 plus 15 is 1. Okay, this looks better. Now, one last thing. That's something that really nice that happened in this problem is that this 6 and this negative 6 are actually opposites. And so this will actually simplify. My next goal, so I made these two things 0. I told you I wanted to make those two 0. My next goal is to make this number here 0. And if I can make this number 0 here, then I'm actually almost done. And so we're almost there. This is really good. And so, oops, sorry about that. So what I like to do then is now find a way to get rid of this negative 6. Well, this one's a little bit easier. So I want to replace this row again. So again, I'm focusing on this row. And all I have to do is take row 3 and add it to row 2. Why is this enough? Well, what I want you to see is 0 plus 0 is 0, so that's good. That stays 0. And negative 6 plus 6 is also 0, and that'll be good. And what I'm trying to do is replace row 3, so I'm going to store everything in row 3. And so now, again, I write down what I'm not going to change. I'm not going to change the first row. I'm not changing the second row. But I am changing the third row. And so what I have to do is it says right here that all I have to do is add row 3 plus row 2, so that's all I'm going to do. So 0 plus 0 is 0. Negative 6 plus 6 is 0. 13 minus 14 is negative 1. And 1 minus 2 is negative 1. Okay. We're actually almost done. Now we can go back and translate to something that makes a little bit more sense to us. Because, I mean, right now this is just a bunch of symbols, but there's a reason for it. You see, now I want to translate all of this back into equations. In fact, this first equation right here, remember that hopefully you remember this from the beginning. I said this is the column of the x's, this is the column of the y's, this is the column of the z's, This line represents the equal sign, and these are the constants. And so now I'm going to translate back to equations, and this first line is x plus 4y minus 9z equals negative 5. The second row is, there's no x's, so I don't have to worry about those. There's just 6y's. So 6y minus 14z equals negative 2. There's no x's, there's no y's. I just have to worry about the z, and it says negative z equals negative 1. Well, which one of these is the easiest to solve? Well, hopefully you said this one is the easiest to solve. And so I'm going to go ahead and take that one. If I want to solve for, I'm going to do it right here. If negative z equals negative 1, then when I would divide by negative 1, I get z equals 1. So there's my solution. I'm going to use that right here. How am I going to use that? Well, this equation, I'm going to do this one in purple. This one is 6y minus 14z, but I know what z is equal to negative 2. I know z is 1, so I can replace that z with a 1. And so now I have 6y minus 14. Actually, let me continue my purplish ways. 6y minus 14 equals negative 2. So if I add 14 on both sides, I get that 6y equals 12. And again, hopefully something that's not too bad to solve. I divide by 6, I divide by 6, and y equals 2. And now I got two of my answers. I got z equals 1, and I got z equals 1, and I got y equals 2. So now I get to use the last equation, the big one, x plus 4y equals negative 5. And so this I'm going to scoot over a little bit. And so here's the big equation, x plus 4y minus 9z equals negative 5. And so now, though, I can replace this z with a 1, because that's what it says right here. And I can replace this y with a 2, because that's what it says right there. And so what I get is the following. We're almost done here. X plus 4 times y, which is 2, minus 9 times z, which is 1, equals negative 5. Okay, so now I get x plus 8 minus 9 equals negative 5, which is x minus 1 equals negative 5. And now the equation is not too bad. Add 1 to both sides. So x is equal to negative 4. And there you go. That is the answer that they were looking for. And you would check by plugging into the original equation. Notice that this, sorry about that, but notice that this takes a really long time. It takes a lot of work. It's not something that's supposed to be very simple. This is why I only assigned one of them. They do take a while. This one itself took me 12 minutes and 30 seconds. So it is something that will take you some time. This is why we're going to learn how to do it with a calculator eventually. Okay? So I hope this helps, and I'll talk to you soon.